Hello, everyone. This is extra practice for our fifth quiz in Calculus 1. Here we have integration, so indefinite integrals, including substitution. Then we have our basics of differential equations. I love these topics. Number one, we want to find a particular solution to the differential equation dy dx is 8 cosine 4x. And then I give you a specific point that our solution passes through. Well, first thing, we have dy dx is a function of x. So we can integrate. So we know that y will be the integral of 8 cosine 4x dx. Now, we could use substitution here. On the other hand, you'll notice we have a little ax on the inside. So when we integrate, we have a 1 over a that comes out. What that looks like here, we can write down the 8. Then we have a 1 over 4. When we integrate the cosine, we have positive sign. Okay, so my answer is 2 sine 4x plus c. Then we use this point. So y of pi over 8. We evaluate. This will be 2 sine, well, 4 times pi over 8 is pi over 2. The sine of pi over 2, well, pi over 2 is here, where the sign is 1. So this number is just 1. So y of pi over 8 is 2 plus c. On the other hand, we know that the solution must go through the point pi over 8 comma minus 2. So we can set this equal to negative 2. Now we can solve. My c is negative 4. Okay, here comes my final answer. Y of x is 2 sine 4x minus 4. This is my particular solution. Next question. We have another particular solution. Okay, here y prime is e to the 2x minus x. So we know y will be, well, we can integrate here. You see, we have another ax on the inside. Maybe I'll write this as a comment. If we integrate e to the ax dx, just like as we integrated cosine 4x, we have a ax inside function. So we have a 1 over a e to the ax plus c. I'll make this a little smaller. If you don't like to use that formula, you can integrate using substitution. Here, I get 1 over 2 e to the 2x. And then I integrate x. We have minus x squared over 2 plus c. Now we can use that this solution must satisfy y of 0 is 3/2. So on the one hand, we can evaluate y of 0. We have 1/2 e to the 0 plus c. This is just 1/2 plus c. And on the other hand, we're told this should equal 3 over 2. Okay, we solve for our constant. Here, we just subtract a half from both sides. My constant is 1. Okay, final answer. We have 1/2 e to the 2x minus 1/2 x squared plus 1. These you could always check. For example, if we evaluate this at 0, you see we get a half plus 1, which is 3/2. And then you can take the derivative and realize you get e to the 2x minus x. So there are checks you can do here. Okay, number 3. Consider the differential equation dy dx is y minus 4 cubed times sine of pi x over 2. Now I give you some information here. There is a particular solution of the form y of x is capital A What is the value of A? And this hint is important. Really, this is going to move us into something we study a little later, but hint, what is the rate of change of a constant function? The rate of change of a constant, the derivative of a constant is 0. So the answer to the hint is 0. Well, how can we use that here? If we have a particular solution that is a constant, we know the left-hand side, which is the rate of change, would be 0 for a solution of the form y of x is a constant. Now, stare at this. Can you find a constant value of y that makes this always 0? Well, sure. Y equals 4. And so my answer is capital A is 4. I love this question because it gets us thinking about things that come later in the course. Okay, now we have some indefinite integrals. Letter A, this is not substitution. What we need to do is write this as a sum of two terms. So here I have 3x cubed divided by 4x plus 1 over 4x. Now, each one of these I need to write as coefficient times x to a power. We did this kind of thing when we were learning to differentiate using the power rule, but here we are integrating. Okay, my first one, I have 3 over 4 x squared. And then the second one, I have 1 over 4 times 1 over x. Now we're ready to integrate. Well, we write down the constant, and then we add a power, divide by the higher power. Okay, careful. We write down the constant. When we integrate 1 over x, we have ln absolute value of x. Okay, plus c. Well, you notice the first term is just 1 over 4 x cubed. And then I have plus 1 over 4 ln absolute value of x plus c. So this is my final answer. Next one. This is substitution. First of all, we see parentheses and an inside function of natural log x. But more than that, I have a multiple of the derivative of the natural log in my integrand. So u is ln x. Du, this will be 1 over x dx. Now you notice I have 6 over x dx. This is 6 du. Next step, we convert to an integral of u. So we have an integral. We have u to the minus 2 times 6 du. I should see your integral of u in your work. We have integral sign, function of u, du. Wonderful. Next step. Here's where we actually integrate. So we add a power, divide by the higher power, plus c. Finally, we go back to x. So you notice this is minus 6 over ln x plus c. This is my final answer. We talked about the 5 steps of substitution, and all 5 steps should be included in your work. Letter C. I think about this as being basic rules. We have a 3x up inside the exponent of e, which, if you wanted to, you could do substitution, but I will approach this as I did on the previous page. Well, the first step, really, I have to rewrite this 5 over the square root of x to the 9th. I need to rewrite this as coefficient times x to a power. So here we have 5x to the, well, it's a 9/2 power in my denominator. So I have a minus 9 over 2. And then everything else I'll recopy. 1 over 6, e to the 3x, plus 4 sine x dx. Now I can integrate. Okay, write down the 5. We add a power. So here this would be minus 7/2. Divide by the higher power. We put a plus. Write down the coefficient. We integrate e to the 3x. We have a 1 over 3. E to the 3x. So times 1 over 3. E to the 3x. We write down the coefficient. When we integrate sine, we get negative cosine. So times negative cosine x plus c. Let me make this a little smaller and I'll make my answer look nicer. Okay, first term here, when we invert and multiply, we get negative 10 over 7 as my coefficient. And then x to the minus 7 over 2. This one is a 1 over 18, e to the 3x. And then I have negative 4 cosine x plus c. Here's my final answer to letter C. Letter D, this is the last one on page 2. You notice up inside the exponent of e is a function, cosine 2y. More than that, I see a multiple of the derivative of cosine 2y in my integrand. This is substitution. U is cosine 2y. Next, we calculate du. So the derivative of cosine is minus sine. And then technically we have a chain rule here. So du will be minus 2 sine 2y dy. In my integral, I have sine 2y dy. You notice this is negative 1 over 2 du. We could just take this line and divide by negative 2. All right, so my integral, we have e to the u times minus 1/2 du. We integrate. When we integrate e to the u, we get e to the u. Finally, we go back to y, which was my original variable. So I have minus 1/2 e to the cosine 2y plus c. Letter E. Let me tell you that I wanted to put this next to letter A, but it didn't work out for spacing. So let me put letter A here and we can look at it and see how letter E and letter A are very different. Okay, so in letter A, you notice the sum is in the numerator and I broke it into a sum of 2 terms. But letter E, I can't do this. My sum is in the denominator. So this is a different strategy here. Let me remove letter A. I don't need it anymore. Here, one place we look for an inside function is in the denominator. And this makes sense for this example because if you take u, let's write it as t to the 5th plus 7. Then you notice du is exactly in your integral. So this is why substitution is the best here. So I have u, I have du, I can make my box. You notice I have exactly du in my integral. Now I'm ready to convert to an integral of u. We have 1 over u du. Now we can integrate ln absolute value of u plus c. Finally, we go back to t. So we have ln absolute value t to the 5th plus 7 plus c. This is my final answer. Okay, 5 and 6 are on verifying solutions for differential equations. Number 5, we want to verify y is x ln x plus 5x is a solution to this first order differential equation. Well, what we need to do is calculate xy prime. minus y minus x and show that it's 0. I'll start by calculating y prime. Okay, how do I differentiate this function? Well, this first term, product rule. So y prime, we have first, derivative of the second, plus the second, and derivative of the first is 1. Okay, maybe I'll write that. Very nice. So that is the derivative of x ln x. And then we differentiate 5x, we have plus 5. Now, you notice this is 1, and then we have this 5 here. So 1 plus 5 is 6. So my derivative is 6 plus natural log x. Now I'm ready to jump into my differential equation. The way we want to do things is start with the left-hand side, do some algebra until we get the right-hand side. In this case, the right-hand side is 0. Here we go. xy prime minus y minus x equals, well, here's x times y prime, then minus y. So minus, we put in my entire function, x ln x plus 5x. And then we subtract minus x. Okay, I will say again what we have here. Here's x, y prime, minus y minus x. Now here comes some algebra. We have 6x plus x ln x minus x ln x minus 5x minus x. Here's when I'm going to start underlining some things. So what I wouldn't do in your work, don't just cross everything off like this. I would underline things that add to 0, because generally, if you're submitting work to be graded, crossed off work says don't grade this. We want to grade the verification. So let me just underline things that add to 0. 6x minus 5x minus x, that adds to 0. And then we have x ln x minus x ln x, that adds to 0. So we arrive at 0. You notice I didn't cross anything off there. I just underlined the terms that added to 0, kind of in the same color. Number 6, and this is the last one on our quiz extra practice. Which of the following are solutions to the second order differential equation? Well, we need to justify. So we might answer only one, we might answer 2, or we might answer all 3. Let's go. In all of these, we need to calculate y double prime and y prime. So I'm going to start with letter I. Y prime is -2 sine 2x. Y double prime is -4 cosine 2x. Now let's jump into the differential equation. Y double prime minus 5y prime plus 4y equals, well, we have -4 cosine 2x. We have -5, this would be -2 sine 2x, and then plus 4y, which is plus 4, well, y is cosine 2x. Okay, what do we have? Similar to the example above, I will underline the terms that add to 0. So here I have -4 cosine 2x plus 4 cosine 2x. I'm left with 10 sine 2x. Now this is not identically 0. So 1 is not a solution. Okay, let's move on. Number 2. We need y prime. We need y double prime. Oh, this one's fast. The derivative is 2e to the x. The second derivative is 2e to the x. I like differentiating e to the x. Okay, now Let's jump into our differential equation. So y double prime is 2e to the x minus 5y prime, 2e to the x, plus 4 times y, 2e to the x. Okay, what do we have here? Well, you notice I have 2e to the x minus 10e to the x, and then plus 8e to the x. Well, we have minus 10. We have plus 10, so we get 0. Wonderful. It says that 2 is a solution. Okay, we need to check 3. I just made that work a little smaller to give me space for number 3. Well, y prime, we have 4e to the 4x. Y double prime, we have 16e to the 4x. Now I can jump into my differential equation. Well, I'm going to have 16e to the 4x minus 5 times 4e to the 4x, and then we have plus 4e to the 4x. Okay, what do we have here? Well, you notice I have 16 minus 20 plus 4e to the 4x. If we add 16 minus 20 plus 4, we get 0. So here we have 0. Oh, I didn't mean to switch colors. So our conclusion here is that 3 is also a solution. The answer to 6 is 2 and 3. Thank you so much, class. This is the end of our quiz 5, extra practice.